there we go. Oh, you got me there. I really thought it broke. I'm not broke, it stopped. Oh, well done. You're so good.
There was nothing, and then the Big Bang happened, and then there was life. So if you read some Bible and all, it says there, let there be light or something like this. Anyone knows Bible, says in the beginning, let there be light. So here you go. And then suddenly, then the universe was full of light. How? There was this Big Bang, and then from there was the creation happened. In the beginning, the atoms are forming, and then eventually the stars, and then finally we have our sun that is formed, and this is present day. We have this value here. So don't worry, the projector didn't break. No load shedding. Okay, so now how old are you?
12.
12. You think you are sure? You are sure you are 12 years old? So do you think I'm older than you? And what if we are the same age? Then we could do the birthday together. What do you think? You agree? How old are you?
12.
12. So you're all 12. But what if we were all the same age? Then we wouldn't be shy to say our age, right? So, unfortunately, you're not 12 years old anymore. That's how old you are. If we would start at 0, and then the universe is created, whatever you are made of, atoms, right? Where did all these atoms come from? From the universe, the Big Bang. So how old are you? You are 13.7 and all these zeros billion years old. You are very old. I hope you are married already. No? You think a girl is married if you are that old? Even I'm not married yet. I'm so old, so not getting married. Anyway, don't worry. Just know that the girl you're going to marry is the same age as you. That's the trick. So there you go. If we start here, the Big Bang, then we can all celebrate birthday together. Because at the end of the day, all our atoms, what we are made of, even this wall, this table, everything you are seeing right now, there's my cameraman that ran away. So I hired another camera.
Yes.
Yeah.
There's a camera than me.
Alright. So there you go. You can understand that we are all in some sense the same age because we all come from the same Big Bang that you saw. And some small details. I won't go into technical information again. If you look in the first 3 minutes, all these maths and physics that you take so many years to study, guess what? The universe was doing what we call quantum physics, meaning it englobes everything that you do in physics, chemistry, even biology I would say, and maths. It was doing it, actually we can even say in the first minute, not even first 3 minutes. So that's how advanced the universe is set up in terms of science. So science is not just these boring things that you study in the books. Science is what you are seeing, what the whole universe is made of. That's the real science. I think these old kids came at the right time. Things are gonna get serious. But like I said, even we are all same age. Alright, welcome. Come in, you can come in more. There's space here. Some chairs, you can sit on the table instead. So maybe move so that you don't stand outside. It's fine, I'll wait for you. As I said, it's not a super formal talk, so move around. And then, yeah, you can grab a chair there. I don't know how long you can stand. You can, if you want, come in front and grab a chair or jump on the table, it's fine, you can sit on the table. Maybe put this file here, pass it to me, that blue file. Yeah, and the glasses maybe. Okay, maybe here. Thank you. There you go. Someone else can sit on the table as well. It's fine. And hang on the ceiling as well, as long as gravity works. Alright, see, you can bring your lunch too, it's fine. You can come. Okay, so we're ready to continue. Alright, so everyone thinks in terms of time, 0 and then it goes up and it keeps increasing. But what about the Big Bang? Does anyone think about that? what
I
happened before. You do, yeah. So tell me, what do you think?
Think, what could have caused it? What could have caused something when there was nothing?
Yeah, you know what, there was nothing, it was load shedding. And then Donnie really got scared. He was running for the power supply.
Yeah.
You understand?
Yeah.
So you think it was fun when there's load shedding?
No, I don't
It's
think
boring, right?
Yeah.
So the most interesting part happened after the light come in. So before it was load shedding, we can't charge our phone and all that. It's not so fun to know what happened there. But it is under research, and if you have this question, you mustn't let teachers kill this question in you. Pursue them, and you never know, maybe you'll be the next Nobel Prize to find out what happened there. Okay, so now we'll move on. So then we won't put a question mark, we'll put your name there, you know. What's your name?
Nicholas.
Okay, next time I'll write it on my slide.
Okay.
Okay, so now back to this Big Bang picture, and just a recap for those who just joined us. So we had a Big Bang. Remember, there was load shedding, no electricity, and then Big Bang, boom. You know, when ESCOM just launched the power, that's how it is. Your phone fluctuates and all that. The same thing, it's actually called a fluctuation. The word, oh, there's the word, it's written there. Fluctuation, and then the stars form, and eventually our little planet Earth formed, and then someday, somehow, you were born. We'll get there. So back to this as a recap again for those who joined. There's our planet Earth there, okay, which is part. This big picture, one dot there is our galaxy, and then one dot in it is the solar system, and another dot in it is the Earth. Another small dot in it is Joburg, right? I'm from Mauritius, so we can't even find the dot on the, if you go look on the globe, you can't find it, it's so small. Now this is another
I went to
picture.
Mauritius once.
Sorry?
I went to Mauritius.
You've been there?
Yeah.
You managed to land on that dot. Oh, I thought the dot was smaller than the plane. Or maybe you got there by a ship. How do you go there?
Plane.
By plane?
Yeah.
Okay, so you can land there. Alright, so this is a bit more advanced, especially for the grown-ups. All these things that we said that there are 1 trillion galaxies in the universe. And guess what? They form only 0.4%. 0.4%. You see, say stars here, of the whole composition of the universe. So what we think we know so much about the universe, guess what? There is so much more to know that we don't know. And please don't be scared. Dark energy, dark matter is not like a evil thing or like a satanic movie or whatever, no. What it simply means is when we don't know what it is, then they call it dark. So that's why they gave this name. Someday they will find out what it is. It's a theory. Once it's proven, then like if you prove that, what's your name?
Jackie.
Then it's gonna be called Jackie energy, maybe something like that. You know, like we have the Einstein equation, so we will be the Jackie equation. All right. So now we move on. That's what I was telling you. There is the known universe in terms of temperature. So this whole energy is there, and that's how whatever I showed you is not made up. They make measurement of temperature. There's something called cosmic microwave background, if you've heard of. That's how we know there's the Big Bang. They didn't make this up. There's whole research that go on. And the most important thing to know is, this is a simple thing that we learn in school. Energy equal potential energy plus kinetic energy, and like if you have a waterfall, or if like I drop this pen, it has potential energy and then it falls. It becomes kinetic energy as it's moving. That's the one you studied, but it's not as simple as that. Anything that's at rest. Okay, I won't go so high. The other equations. Basically, everything that's at rest has potential energy. The one that you study for this pen, that's called gravitational, because it's to do with gravity. But then in a magnet, there is also potential energy, and even in the whole universe, there is what we call energy at rest. It's again called potential energy. So you will see that there's things that you learn that's very simple is also used in very advanced research. And now we come to this. Now, what's interesting about this? Anyone knows what is that? Yes.
Different ways of light. Well,
You were not there, yeah, you're almost there.
well,
Or you just read my slide. like this little boy was doing. But sometimes I write the wrong things to confuse you. You were close though. Anyone else? What is that?
Lightweight.
I heard, see? Don't be scared. There is no wrong, right answer. Express yourself.
Lightweight.
Light waves. That's similar to what you said, yes?
Radiation waves.
Radiation waves, that's more precise. Anyone else? What's that?
A radiation wavelength.
Wavelengths, yeah, you're getting more technical. Anyone else? Doesn't mean these answers are wrong.
Electromagnetic waves.
Yeah, very good at reading. That's very good. See, you can be the Jackie equation. So the first thing to be a very good scientist is you have to be a very good observer. So if the answer is there, why work hard to find it? Just read the slide, right? You got that, he knows. So what you said is not wrong, waves, but why it's not fully precise is when you say waves of light. I know many people say that, but what can be confusing is that's the only part that is waves of light. Meaning what you see, the red, blue, the rainbow colors basically, like right now you can see your friends and they can see you. That's because of the, what we call visible light. So this would be visible light. Now, what do you really see when you look at something? For example, you look at this door, what are you seeing?
You see the light reflected off of the door.
Yeah, so what are you seeing?
You're just seeing the light hitting you in the eyes.
You're seeing light,
Yes.
not hitting you. If they hit you, you'll fall. It'll be like boxing.
They don't have mass. It's not like they could hurt me.
Are you sure?
Let me prove it. I'm gonna stare at the sun for a few minutes.
Sorry?
Let me prove it. I'm gonna stare at the sun.
You will stare at the sun, and then what will happen? Are you sure they don't have mass?
I'm sure.
Do you agree these light particles,
Yeah.
they are photons, right?
Yeah.
Are you sure they don't have mass?
I'm sure.
I wouldn't be so sure. I will do some research. Okay, so these are questions that sometimes in school you are told something, but it's not necessarily so. Sometimes there's more to it, there's more. And this is why it's very important to always keep the open door. Meaning everything that you learn, always think there may be more, there may be more. Like for example, we learn that light doesn't have mass. But is it really true? The scientists are not sure yet. For example, if I ask you, what time is it? You look at your watch, right?
Or phone.
Oh yeah, phone now, the one on the watch. No, except if you have a smartwatch. So what time is it?
108.
Yeah. Yeah, when I.
And if I change the question and I say, what is time?
It is an abstract concept which is the order in which things happen before and after right now.
That's a very good try. I think you can get the Nobel Prize. Guess what? This was the main page of a magazine called New Scientist recently, maybe 1 year or 2 ago. What is time? Because actually scientists do not know exactly what is time. They are still finding out, and that's why they are so late. Now, getting back to this. What we can see is, like I told you, what we see, things, we see in the wall, these fall under visible light. But what we do not see with our eyes is also waves present in the universe. For example, you listen to the radio, or you're using your phone, that's also radio wave. Microwave is also your phone, or when you're just cooking food in the actual microwave that you probably know. But there are many other things that are microwave. Like I said, the very Big Bang is known because of the cosmic microwave background. And then infrared is again in the oven, or if you are exposed in the sun, you feel hot. When you feel hot, that's because the infrared is reaching you. Ultraviolet also from the sun. And if I'm not mistaken, the dogs, that's how they see the world. Anyone knows about that? The dogs or the cats, I may be wrong about that, you can check Google, like I said.
No, it is wrong. They just don't really see in the same amount of visible light. They
don't see visible light.
They do see visible light, but differently. Like if we were to look through a cat's eyes, we would see its eyes because that would make sense to. Unless okay, I'm just confusing myself a lot again.
Yeah, I can say.
Yeah, I'll shut up.
Yeah, no, you can talk. It's fine. You can all talk. That's why I say it's the interaction section, and I encourage that you engage as much as you can. So yeah, I can't remember if it's the dog or the cat, but they don't really see visible light like we see colors and all. This is why, for example, if you're scared, you go near a dog and you start bark, but if you're fine, it won't bark, because it's seeing the temperature of your body, which is ultraviolet and infrared combined. And then there's the X-ray and gamma ray, which is used in the hospital to do scan of the brain or the body. Also, gamma ray is radioactive, as you know, and this is why, for example, when there is an atomic bomb. That's the other thing. You must. There are people who have this tendency to think that physics is only used to study to make things like wrong and bombs and war, but that's not true. The phone that you use is everything
just,
about physics.
Answering specific questions.
Sorry?
Physics is just a smart, fancy way of saying answers.
Fancy way. I like that. Well, sometimes it's not so fancy. Sometimes it can be boring too. Okay, so now we will move on back to our tree. Okay, for those who are not here earlier, we started with a tree, except it's a different tree. And there is, what can you see?
Fruit.
Fruit. Someone said the actual fruit. Yes?
Berries.
Berries. Okay, I myself don't know what fruit is that. So maybe you're right. Okay, so that's the tree. We are back on planet Earth. So earlier we went from the tree to the Earth and then to the planets. For those who are not there, just maybe I'll show you the slide later if you want. Now if we go into the tree, what do we see? What can you see? What's the background? What's that? That's a leaf.
Yeah.
And if we go deeper in the leaf, you see a cell. So now we can go inside. When we go inside, that's a different science again. That we study. When it's life, we say biology. When it's not life, it can be chemistry or even physics. Now if we go deeper in the cell, the main composition of the cell is water. You all know that. Your body is mostly, I think, 70% of water. But that's not, this is not as accurate as saying each cell of your body is 99% of water. So that's a lot. 99%. And in terms of weight, it's 70%. Now, if you can go deeper in this water molecule, I won't go in the technical, but just to show you, it means there are atoms. And then this is a photograph of an actual atom. They use what we call a quantum microscope. I don't know if you've heard of this. There is the normal microscope you use in the school to look at a cell. Electron microscope is to look at atoms. And this is one of the latest technology where you have a what we call a quantum microscope. It can look even smaller. Now, this is a drawing you probably all know that small. Now, what does this have to do with all this very advanced kind of information? What is this?
It is a water cycle.
Water cycle.
Yeah.
So did you see there's water here?
Yeah.
So what does this have to do with this?
Well, it has water, and that water is evolved.
Other people, others, you can also answer. He doesn't have to answer everything. Right, we must give a chance to the others. Yeah, talk, don't be scared. What's your name?
Oh, McTinnan.
Say again?
McTinnan.
Martin.
Yeah.
Alright. Are you enjoying this?
Yes,
Okay. So now, what the point of this drawing is to show you that the water that was created is the same water that falls as rain, goes in the rivers, we drink it, and then it evaporates before we excrete it, of course. Well, after, and then it goes back to the sky. So sometimes the water that we drink may end up in the body of this little boy. You agree? So think about that. And this is the same thing that applies for energy. Because energy cannot be created or destroyed, it means the same energy in the universe that keeps rotating. The same energy that was in the Big Bang, the same energy is in all of us present here. So the atoms may be different, but the energy, remember before the Big Bang it was just a dot, actually even smaller. All this energy was compressed, so it means we're all together there. And then this energy got propagated, you saw the expansion, but it just goes like a cycle like that.
People really describe that universe as a dot because that was everything. And I can't really make a shape as everything.
Say again? The last part, what you said?
I can't think of a shape that is made out of everything.
Yeah, that's the thing, there was no really shape. But for your understanding, we said dot so that you can try understand the universe is so big now, there is all this energy, but all this energy used to be in just one dot. So it's just a concept to understand. It does not mean there was an actual dot there.
Yeah.
Because to say there is a dot was something. So there was actually nothing.
So it would be at the beginning of the universe, all the energy of our universe was an infinitely small point.
Yeah, that's called as point of singularity. And that's what, if you want to learn about black holes, in a black hole also this is what is happening. There's a lot of energy concentrated at one simple point. It's called a point of singularity. So that's basically it. My talk is finished. Now I'll just take questions. These are some just other slides that relate to science again, biology. So if you have questions, I can attend to that as well. A whole bunch of different cells that you have in your body. The stem cell being very important. So by the way, for those of you who think you are a boy and you can never be a mother, guess what? No, actually we are all mothers because we all have stem cells. At the very creation, you are the mother. That cell that you get, and then it's called a mother cell. It's that cell that will create all the other cells.
From now on.
So please don't be jealous of the girls. Okay? And girls who can't be mothers also, you can chill. There it is. Alright. And you see the cell become the other organs, and then it becomes the organ system. That's the biology class. I'm not doing that there here, I'll do it online. So I'm just showing you, oh yeah, this I wanted to cover that as well, DNA. So in that cell, if we go further in, there is smaller and eventually there's DNA. Now what's interesting about DNA, think of this small cell, it's so small, this DNA which is supposed to be smaller, but it is like a rope. Okay. It's like this and then it's entangled with each other, it keeps turning. So much that, you see this, if I pull this now, it will become so long. Okay, you hold one part. I'm sure it will go till there. It's entangled, you see. But I want to show you a concept. How is my battery doing there, by the way? Mr. Cameraman? Is there still running or why do you have to plug it? Okay.
It's okay for now.
It's okay for now.
For now. For now.
For
now.
Okay, but I'm almost done, so okay, how did you do it? Pass it behind, let's see how far you can. Pass it to your friend behind. Pass it behind. Okay. Now you see I'm in front and you are behind there and the rope reached you, right? But we couldn't get outside. Now this will be like 5, 10, 15, 20, 25, seconds. That's like say 55 centimeters. Sorry, I cannot count anything. Very hard. Now why I'm showing you this? Now this DNA which is in your cell, and there's not one of them, there's so many in every cell, right? If you have to pull all the DNA in your body, say total length of DNA in one human, it would reach, you can take it to the sun and bring it back to earth 66 times. Think about that. 66 times. So you have the actual distance here because the sun may look right here. But that's in meters. You can't even put a name there because it's 10 power 13, meaning there is so many zeros. You have to keep adding so many zeros. But think about that, 66 times you can go to the sun and back to earth. Remember, not just go, come back. That's how long the DNA, all the DNA in your body added together is. So think about that. And that's just technical again information about the DNA. If you go in the bonds, Yeah.
What would you call this? What would you label this? What you spoke about? What is it? Is it about quantum physics? Is it about?
Yeah, so I don't like this one. I don't like to give a name because
okay.
this is science. You can
Science.
call it quantum physics. When you go in, this is why I have this. For example, if you were to study, now just to give you an idea as careers, like you said, if you want to study what happened before the Big Bang, that would be astrophysics. If you want to study DNA, that would be chemical engineer or biotechnology. And if you, erase on this. If you want to study deeper in the atom, the hydrogen bonds, what's happening, then that would go. Quantum physics is, quantum actually means small. So when you are studying the small, then this is quantum physics. But even quantum physics is so vast right now. There's quantum biology, which studies how life started at the atomic level. There's quantum machine learning,